Okay, hello. Welcome to our statistics notes. In this video, we're going to be talking about analyzing quantitative data. All right, so suppose that we have a random sample of quiz scores from a class of 136 students, right? And these are the quiz scores that are listed, right? We want to calculate the mean of the sample. All right, anytime you see this word calculate, it is necessary to show the formula that you're going to be using. So the calculation of the mean of the sample, because this is a sample, we would be using the symbol x bar, right? And that is going to be equal to the sum of my particular data values divided by my total number of data values, right? And that sum, right, will be this 86 plus 84 plus dot 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 plus all the way to 93, right? I'm going to add up each of those and divide by how many total I have in my sample. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of this divided by 9, all right? And of course, I could come over here and use a calculator to help me with that calculation and say 86, right, plus 84, plus 91, plus 75, 78, 80, 74, 98, 93. Right, so we've got all our data entered in there. All right, we press enter. So that's going to be 759 divided by 9. And that will be approximately 84.3. Okay. Now, how many decimals places should you use? Generally, you go to one more decimal than what your data is given to. So this data is given to my units digit. I'll take my mean to the next decimal place. Okay. Then for the next piece, we see that we're going to calculate, once again, the standard deviation of the sample. When we're going to calculate something, it is necessary to show the formula that we'll be using. Because this is a sample, the formula that we'll have will be with this S, right? And then X just means my variable here, right? So my standard deviation is going to be given by the square root of a summation of my particular data value minus my mean squared all over n minus 1. All right. Notice the x bar here because we have a sample. Notice the s because we have a sample. X sub I, once again, is the information regarding my particular data values, right? So really I'm looking at the difference between a data value and the mean, squaring those differences, adding them all up, and then dividing them by one less than my sample size, okay? So in order to do that, it helps to make a table, right? And we can come over here and we can say, okay, so if I have my x sub I, right, with my particular data values, then I can calculate x sub I minus x bar, right, finding those differences. Then I can calculate x sub I minus x bar squared, which would be finding the squares of those differences, and then I'm going to end up wanting to have that sum. All right, so here, let's go ahead and list our pieces out. All right, let's separate this so we have 86, 84, 91, 75. All right, we have then 78, 80, 74, 98, and 93. All right, remember that x bar was equal to 84.3, so we're going to find each one of those differences. Okay, now we're going to show you on your calculator how you might be able to find those differences a little bit more rapidly rather than just saying, hey, 86 minus 84.3 is 2.3, 84 minus 84.3 is negative 0.3. All right, we could do it in that form. But another way that we could do it is to use our calculator, right? Come in, go up and let's clear the calculator's input information. And I could come in and go ahead and input my data. So 86, 84, 91, 75, 78, 80, 74, 98, 93. All right, so I input my data, and then for list 2, I can come up and highlight to the top of list 2 and say that that's going to be second list 1 minus 84.3. All right, that should be a 0.3. And so now what I'm saying is I'm going to, into list 2, put those differences. All right, and I can put that down. And so I see I have those values, right? And 86 minus 84.3 is not 2.3, it's actually 1.7. So that helps you check any types of careless arithmetic mistakes that you might have, right? So we can list these out. We have then 6.7, negative 9.3, negative 6.3, negative 4.3, negative 10.3, 13.7, and 8.7. Okay. Now, interestingly, if you add these all up, right, if you add all of those values, right, and a way that I can add all of those values is to come over here and I'll go into list 3 and I'll say, right, second list, and say, let me find the cumulative sum. Right, and I'll say, well, let me find the cumulative sum of list 2. And it goes through calculating the cumulative sum. And I end up at a cumulative sum here of 0.3, but that's because of the rounding that we were having in calculating this as 84.3, right? That really and truly the cumulative sum of these differences should be equal to 0 if I was not rounding, okay? Now, we also need to calculate this x sub I minus x bar squared. And I can do that. Once again, I'll come to list 3 and let me clear list 3, right? And then what I can say is, well, list 3 is going to get list 2 times itself, right? And so now I have those numbers, right? 2.89, 0.09, 44.89, 86.49, 39.69, 18.49. All right, and we get the rest of those values written down. Okay. Now what we want to do is to go ahead and add up all of those values. So I could come over here into list 4, right, go to the top and say I want to have second stat, which is list. I want to have the cumulative sum of everything that is in list 3. All right, so I can do that, and it comes through and it gives me my cumulative sum is 562.01. Right, so what am I going to do with that? Well, this 562.01 is the cumulative sum that I'm wanting for my standard deviation. So my standard deviation is going to be the square root of 562.01 all over, right, n minus 1, my sample size minus 1, so 9 minus 1, right? And this value, s sub x then, is going to be equal to the square root of, let's go ahead and come to our calculator, and we'll say 562.01 divided by 9 minus 1, so let's instead set this up in a better fraction format, 562.01 all over 9 minus 1, which of course is 8. So I could have just said that and gotten to the same piece, and I have 70.25 approximately. All right, so I have 70.25 approximately. And so I can come over here and say that's going to be the square root of 70.25. And if I take the square root of that number, that gives me about 8.38. All right, so what I have then is that my standard deviation is approximately 8.38, and the square of my standard deviation would then be that 70.25. This gets called the variance, and this, right, of course, we said is that standard deviation. So there's the calculation of the standard deviation for our work. Now, what about the 5-number summary for our data? Right? The 5-number summary for our data, what we have for doing that is that we can come over here and we can say, hey, here's my data. I need to go ahead and organize this in order from least to greatest. All right, so I'll do it up here because we can see our data. We can come over here and see, hey, what's the smallest value? The smallest value is 74. Then I have 75. All right, then I have 78. All right, then I am at 80. All right, after 80, it looks like 84 and then 86. All right, and then finally I have 91, 93, and 98. Okay, so I'll go ahead and take those values and write them down so I can get my 5-number summary. Okay, so once again, writing these out, 74, 75, 78, 80, 84, 86, 91, 93, and 98. Okay, my 5-number summary includes a few things. It includes a minimum, it includes a quartile 1, it includes a quartile 2, which is the median, right? It includes a quartile 3, and it includes a maximum, right? Well, the minimum and the maximum are fairly easy to determine. Here's my minimum, right? My minimum is 74. Here's my maximum. My maximum is 98. Okay. Past that, my median is going to be my middle number when I'm organized from least to greatest. Because there are 9 numbers here, I'm going to go to my middle number, which is 84. So that's my median. Right? Then, for our purposes, the quartile 1 will be the position for the median of the bottom half of my data. So if I look at the bottom half of my data, right halfway in between there is going to be quartile 1. And if I look at the upper half of my data, right, then coming down from there, that's going to be quartile 3. Okay, well, halfway between 91 and 93 is 92, so that's quartile 3. Okay, now there are other ways of calculating the upper and lower quartile that you might learn in other stat classes, but this is our approach. Okay, and then halfway between 75 and 78, we can tell is 76.5, and so now we would have our data. Okay, so we've talked about calculating the mean. We've talked about calculating the standard deviation. We've talked about the importance of showing the formula if it tells you to calculate, right? Showing the formula if it tells you to calculate, right? Finding the 5-number summary, right? It doesn't say to write, it says to find, so we need to kind of show our work. Please always list it in order. Okay, and of course, all of this, right? All of this we could do much more efficiently if our question simply asked us to write this information. If we were to ask to write or to state, we could use our calculator to do all of this, right? So how could we do that? Well, within our calculator, here we have our setup, right? We have our data values. Well, we already talked about putting that information into our stat list, right? And we'll show you a few things that you can do, okay? Our data was in list 1. So one of the things that I can do is to come over here and to say second list once again and come back to these operations, and I'm going to sort ascending my list. All right, so if I sort my list 1 in ascending order, now, when I go to my stat list, I should see that my list is sorted in ascending order. That can help me find my information a little bit easier if I'm needing to do that 5-number summary. Right? Additionally, if I want to calculate the one variable statistics for my data, so calculating the mean, calculating the median, all of those things, all I need to do is to come over here to the one variable statistics, select the list that I'm going to work with, right? If my information was in list 5, I could select list 5. My information, however, is in list 1. And then I can come and calculate, and so now I have my one variable statistics. I have my X bar, 84.3. Does that match what we had? Yes. Right. I have my standard deviation, 8.38. Does that match what I had? Yes. Right. I want to point you to a piece here that this capital S refers to the standard deviation for the sample. If I was working with the population, I would have a slightly different formula, and my calculation would be for sigma, the standard deviation of the population. All right. Then I can arrow down and I can look to my 5-number summary, right? If I come over here and I check out my 5-number summary, what do we have, right? I do have my minimum, my quartile 1, my median, my quartile 3, and my maximum. Right? That 5-number summary we'll be able to use for creating box plots and doing those sorts of things. All right? So how can I do this more efficiently using my graphic display calculator? I can do, right, sort ascending my list to sort, and I can do my, right, so we'll show you once again where that is. If you go to stat, you can also see sort ascending, right? And you can go to calculate, right? And that calculate would be my one variable statistics, right? So that's how I could do this work much more efficiently using a calculator. Okay. Thank you very much for your time. As always, ask questions for clarification when you need. In the following videos, we will continue more information.